Okay, so we are in the last section of chapter 2. We're talking about rational numbers now in decimal form. So we're moving from just using fractions to decimals. That's where we're headed. So what is a rational number? A rational number, Brian? Rational is fractional. So what's the operation? Divide. So is the number 10 rational? The number 10. Is that fractional? What's the denominator? 1. It's 1, right. So if we divide 10 by 1, what do we get? 10. So we know everything about that number, don't we? 10. What comes after the 10 in 10? There's a decimal, right? What comes after that decimal? 0. What comes after that 0?
0.
And so on. We know everything about this number, don't we?
Yes.
Okay. All integer numbers and fractional numbers are rational. So if we divide an integer like 10 by 1, we know everything about that number. It's 10. 10 divided by 1 is 10. We're going to see fractional numbers, and we will discuss that in just a second. But because this is the rule for rational numbers, all rational numbers could be written as A over B. What is true for B because of this being a rule? B, who else knows? Who else knows? We've said this a few times. Okay, so 3 in the back row now. And Audrey. Audrey, what is it?
B times A.
No. Stuart.
B does not equal 0.
Good job. Whenever we have a rule and a variable shows up in a denominator in that rule, then that denominator variable may not equal 0. If it equals 0, what would we say about that fraction? Undefined. So we can't really work with it if it's undefined. There are 2 types of rational numbers. When we go divide, we might have a number like 10. 10 divided by 1 is simply 10. And it just ends. It's 10. That's it. It's over. We call that type of rational number a terminating decimal. Like the Terminator. Who has seen one of those movies, The Terminator? Arnold Schwarzenegger, who was governor of California, was the Terminator. I never saw those movies. But why was he called that, Jake? He terminated people. So what does that mean for someone who's never seen the movie? If you terminate a person, what are you doing? You're ending their life, okay? So to terminate means to end something. And in this case, we're talking about numbers that are ending. So we could divide 2 numbers. And an example of 2 numbers we could divide are 1 over 2. 1 divided by 2. Most of us actually know the decimal value for this before we do it, but let's imagine you never knew, so we would go divide the number, right? Can 2 go into 1? So we could say 0 there. So what do? We put the decimal and we drop a 0, right? So can 2 go into 10?
Yes.
How many times?
5.
5 times. So 2 times 5 is 10, and we find out 10 minus 10 is 0, right? So there is no remainder. With a terminating decimal, we have a number like 0.5, and there is no remainder. We know everything about this number. 1/2 is 0.5, and we know everything about it. If we were going to add a digit after the 5, what number could we put? 0. And we would just put zeros infinitely if we wanted to. Okay, so that's a terminating number. The other type of rational number is a repeating number, repeating decimal, which are kind of fun. So when we go and look at these, again, they are a number divided by another number, but rather than a remainder, let's see what happens. So 1/3 is a simple example of this type of number. 1 is being divided by 3. So we're gonna go try some long division with this. Can 3 go into 1? No, so we put a 0 there. Bring up that decimal. Can 3 go into 10? How many times?
3.
So 3 times 3 is,
1.
so we subtract, and we get 1, which is what we started with in this division. So we drop down the 0 and we have 10. 3 goes into 10 how many times?
3.
And 3 times 3 is 9. And we still have 1. So we could add another 0, and what would we get next? 3 and 3 and 3. Do you see it's repeating? So one way to write this is 0.3 with a repeating bar over the top. There's one number repeating. It's the number 3. Okay? Do we know what the number, if we were to write this number further out, what would the millionth digit to the right be?
3.
And what about the 141st number on the right? It would be?
3.
Do we know everything about this number?
Yes.
It's rational. We know everything about the number because we know all those numbers will be 3. So if something is rational, we understand everything about it. It either terminates, so we know the entire number, or we know what to predict the millionth number to be because we know the pattern. Okay? That's what rational means. It's an understandable concept. Okay? So how do we write fractions as decimals? All those other types of things. If you want to change this 8/9 to a decimal, what do you do? Decimal. Good. We divide. So the top, I like to say it's like the top dog. The top is in the doghouse. It's funny, some people will actually put the 8 outside as the divisor. So you've got to find some way to remember this. The top is in the doghouse, right? Top dog in the doghouse. 8 is being divided by 9. And can 9 go into the 8? So if it can't go in, we could put a 0 in that place. And now remember, we're going to add a 0 and so on. So how many times is 9 going into 80? Colin?
72.
Okay, so 9 times 8 is 72, he says. And then what do we get next? 8, a remainder of 8. So we could do this again. 9 goes into 80 how many times? 8 times 72. And do you see we're having a repeating remainder, aren't we? So how can we write this number, Izzy?
0.8.
Good, repeating bar over the top. Okay. Go ahead and try this. Right? So when you do this division, you end up with a terminating decimal. So you continue to divide until you either see a remainder reappearing, and now you know you're going to have a repeating decimal, or until you have a remainder of 0, and then you have a terminating decimal. Okay? How are we going to write a mixed number as a decimal? Emily?
You change it into an improper fraction.
You could do that. You could change it to an improper fraction and divide, but what is the part of this number that will be a decimal part?
With the dog, you just divide 2 and 5.
Right, right. So we know that we have 4 as a whole number here. It's 4, and we're going to end up with 4 point something. We've got to change the 2/5 into its decimal equivalent. So this is 4, and how do we change 2/5? There's a really fast way, but if you don't know it, you could just divide, right? So go ahead and do you know the fast way, Aiden?
I guess you could put tenths.
You could just change it so it equals some tenths. That's right, and we're going to talk about that soon. But let's go ahead and divide, because I don't think everybody's thinking of that method. And so can 5 go into 2?
Yes.
No. So we would say 5 can go into 20 how many times? And there you go, there's no remainder. So the answer is 4.4. Okay? What Aiden was saying was, if you find the equivalent of 2/5 equals how many tenths? 5 times what equals 10? So 2 times 2 equals 4. And 4 tenths we're about to talk about this. 4/10, if you listen to that number, it's giving you the place value, isn't it? 4/10, it's in the tenths place. So when we change a number to have a 10 denominator, then we know the digit that's in the tenths place. You could do the same with hundredths place, couldn't you? Okay. The only thing different here is now we have a negative, right? So we can't forget, it says -5 1/3. We can't forget the negative in our decimal equivalent. So go jot it down. -5 and, do you remember what 1/3 is? We already did this. -5 and what is 1/3? 3 repeating. We just did it on the previous slide, so we could just write that right in since we have already done that division. -5.3. Does everyone understand how we are changing these fractions? So we can go the other way too. Can you take a decimal number and write it as a fraction?
Yes.
Like for instance, if I told you, if I gave you this, if I give you this number here, 0.1, can you tell me what that is? I'm saying 0.1, but there's a better math way to say that. How can you say it, Kenzie? 1/10. Did you hear that? She said it 1/10. So now how do you write that, Kenzie? So you could write that as 1/10. You see, we're naming the place value. So if you can say it, you can write it. Name the place value. So here's example A. Can you say this for us, Alex?
65
Well, you're actually going further than, if you were to say it as a decimal, you would say 65 whats? Hundredths. You're actually already taking it to a fraction, what you said, right? So he said that this equals 65 over 100, and that's because if we just say this decimal, we always name the entire number that follows the decimal, and then name the place value of the last digit, so 65 hundredths. So he said you could write it as 65 over 100, right? Now, is there anything else we could do with 65 over 100? Do you see that? What can we do with that? Simplify. You can reduce it, okay? And what factor goes into both of these numbers? 5. So how many 5s in 65? 13. And how many 5s in 100? 20. Okay. So let's try that with, go ahead and try that pause the video, come back and check your answers. Okay, so this one, if we're going to change B, -1/7, into a fraction, well, we have what type of a number when we do this, Olivia? A mixed number. So we simply say we have -1, and then the fractional piece is what follows a decimal. So Olivia, what is the fractional piece? Good job. So we would write that as 7/10. 7/10 still sounds decimalish to me, so do you understand? Okay, so 7/10. Can we reduce 7/10? So we just leave it as is. Okay? Izzy? Good for you. That's what you should do, is get ahead. Okay, so Izzy, how do we write this one here? 100, and then, can you simplify that? And what would you divide top and bottom by? And so you would say what? Good job, 31/50. We could simplify. Okay, try one more and then we'll check. And there you go, very good. Okay, this is another little interesting thing about repeating decimals. The period of a repeating decimal is the number of digits that is repeating. So if you're asked to find the period of 0.13, it's going to, that's saying right there 0.13131313 eternally, you know? That's what it's saying. So we would say that the period of that is 2. That's how many digits are repeating. So what would the period of this number be? Can you see? This has not been written, 0.333 has not been written with a line over the top, so you have to figure out how many digits are repeating and how many are? 1, right? So the period of this number is 1. Let's see if you can find it for number 39. 0.459 with a line over the top is saying 0.459, 459, 459, 459 forever. And so the period of this is 3. How about number 40? The period of that is
2.
no. Look at it closer. It says 0.21 with a line only over the 1. So the period is 1. So what's the next digit after that 1? 1, not 2. It's 0.21111 forever. Isn't that interesting? Okay. And finally, can you see that? And so the period of this one is 3 because it's 857 repeating over and over again, that block. Okay? So there you go.